In 20.9 of ERStudio, we now support JSON complex columns in traditional databases. Many modern database platforms, traditional databases, allow you to type columns not only as simple data types like varchar or date, but you can type them as a more complex data type such as JSON or variant. And many database platforms are actively encouraging users to store raw JSON data in the databases. And this presents a problem for our data architects. Enterprise data modeling tools at the moment will allow you to reverse engineer the first order tables and columns, but then have no visibility at all of any data within those tables and columns. In this release of ERStudio though, things are different. So we've got two use cases for this. The first one is documenting embedded JSON data. So we want to be able to reverse engineer the embedded JSON structures alongside those tables and columns. So we've got a full documentation of all of the data in the database. And that's going to help with our data governance program as well. We can then start mapping those fields in the embedded JSON to business terms and populate the data catalog. Let's go and have a look at this in the product. So here we are in ERStudio Data Architect. We've reverse engineered or even designed a Snowflake database here. So this is the physical model. It's a very simple e-commerce system. We've got a table for products and we've got a table for sales orders. And at this point in time, we've got no awareness of any sensitive data in this database. We've got no security problems. We don't really need any security on this database because there's no sensitive data. The developers, when they asked us to design this database, asked us to create a column called order data of data type variant, which we did. We've now implemented this database. So let's go and have a look at the database in Snowflake. So here we go. I've just run a little select statement on the sales order table, and I can see all the columns that I specified in the design. I can run compare merge in ERStudio against this, and it'll tell me, yep, it's exactly how you designed it. Now, the thing is, the order data column here of type variant seems to be storing a lot of JSON data. Okay, and I can see here just by looking at the database itself, there's fields like address line. Okay, this is starting to worry me. Is there any sensitive data in this particular column? With Data Architect 20.9, when I reverse engineer databases of type Snowflake, Postgres, etc., I've got a new option. I've got an option to say, in this database, if there's any columns of data types that could store JSON, then do you want to go and have a look at the data in those columns? So here we've selected variant data type. We can specify how many records we want to parse. So we might have some records with JSON with incomplete sets of fields. So we might want to parse a number of records to get a complete set. We're also really interested in common objects across those JSON structures. So here ERStudio will go and look at JSON objects across different columns and see if there's anything that looks common or similar, and then combine them into some single objects. So now I've got a different story. I can see that our order data column here now has a little plus sign next to it. And I can expand that and see all of the JSON fields that we've found. Very quickly I can see, wow, okay, there really is sensitive data in here, as well as those addresses that we saw. I've got credit card details, credit card number, even the CVC code. Gosh, I've got the gender of the person, highly sensitive data in European GDPR laws. I'm even storing passwords. Gosh, are these passwords in plain text? We don't know. So I now know that I've got potentially very sensitive data in this embedded JSON data, which before I had no visibility of at all. What I could do now is check this into the repository, map it to appropriate business terms, and then examine those business terms for the policy of the organization and start building out a governance plan for this particular data asset, which might include adding more security to the database. And of course, ERStudio also gives us a logical model every time we perform a reverse engineering operation. And this logical model now gives us a map of both the first order tables and columns and the embedded JSON data. The next use case involves designing a database that's going to contain embedded JSON data. So I'm going to go through the usual design process for a data asset, starting at the logical model, deciding what information is going to be in this data asset. And I can make decisions on which of this data is going to live in standard tables and columns and which is going to be put into embedded JSON structures. And then once I've created that design, I can then generate all the code I need to give to the developer to realize this data asset. I can give them the SQL code or the DDL file, and I can also give them JSON files, both the sample instance files and schema files for each column. Let's go and have a look at that. Here's a logical model in ERStudio. We've used the same approach that we've been using for Google BigQuery and Databricks and Mongo and JSON structures all by themselves. So in this model here, I've got books that contain chapters and sections. Books are checked out to patrons of libraries, publishers, libraries and patrons all exist at addresses. And we're using the containment flags on these lines to state which of these relationships will implement a containment or nesting relationship in whatever physical platform. And we've been using this approach for Databricks and Google BigQuery, for instance. So here I've generated from that model a Databricks model. Okay, so ERStudio works out based on all of those containment relationships, which are the top level tables and then what are embedded or nested structures, and then utilize whatever features of that platform to implement those nested structures. And this is really important in modern platforms, so for performance and flexibility of the operations of that data asset. So for instance, I could create all of these entities as standard tables. If I want to read my list of publishers and get the addresses, these are separate tables, I would execute a join statement. And there's performance problems associated with join statements. In platforms like Databricks and Google BigQuery, I might want to choose to embed the address as a nested structure in the publisher. Every time I read a record of a publisher, I want the address to come with it. So performance is improved. And we can do the same thing with our embedded JSON in traditional databases. So going back to Snowflake, again, I can execute, generate physical model, and I can choose for the tables. How do I create the tables? We can create them all as tables or follow the rules associated with our containment lines. And here we go, it's generated our Snowflake database. And we can now see for those contained entities, address, it's created a simple column for each using the variant data type. And in there is a JSON structure with that address structure. And we're using the same objects for each of these columns. So we've created a standardized complex type effectively and then reuse that across these tables. Within our book structure here, we can see that chapter and checkout, again, created as simple variant columns. And then within them, here's the structure of the JSON that's going to populate it. From this model here, we can then generate the database. So I'm going to generate all the files. This is my local machine. And again, I've got options. How do I want to generate the embedded JSON data? I want to output the files. I want JSON schema files. Which schema version do we want to output? For the DDL code for the Snowflake database, it's just as I expect. It's just giving me the tables and the columns, and I've got my two variant columns for my book, and my address has for my library, patron and publisher tables. If you go to Windows Explorer, then I can see that I've got a file for my DDL, Snowflake with embedded JSON. It's also created me a folder, and it's created me JSON schema files for each of those columns. I've got one single JSON schema file for the three address columns, and then there's my chapter and checkout. Here's that simple JSON schema for our address column. So I can now give this package of files to the developer, and they can go ahead, deploy that database and use the JSON schema files to validate the schema that they're going to put into those columns. So ERStudio's support for JSON complex columns. We can use ERStudio to both document embedded JSON in traditional databases like Oracle, Snowflake, Postgres, etc. And we can also design traditional databases and make decisions on which information we embed in JSON data. This is going to help us improve our documentation and governance for data assets, and really allow us to take advantage of the flexibility of JSON and take control of JSON projects. Thanks for watching. Any questions, contact us at sales@idera.com.